How have you guys been? It's been, I think, 7 days, I guess. 6, 7 days. How have you guys been during the week? Good, good. Nice, nice, nice. Were you able to write the articles? Awesome, awesome. You can post them in the group at the end of the lesson. I'll read them. Um, I'll be able to read them. How about the programming assignment? Did it make sense? Or does PHP to some extent make sense right now? Hello? Uh, it does, it does. And how was it? Was it simple, or how was the programming assignment? It was okay. I guess too simple, right? I'll give a different one. This week I'll give a different one, but it will still be based on our weekly approach. Where we have an end of week article and a small assignment. For this week's assignment, it will be focused the theoretical side. On the theoretical side, in case you encounter a challenge, feel free to nudge me in the group. That's one. Two, I remember, so for this week's article, it will be more or less talking about databases, right? In this case, we'll be busy it on two structures. The first structure is a NoSQL kind of structure, and the other one is a SQL kind of structure, or a relational database kind of structure. So there are many other different types of database types of structures, and in this week, we're going to focus on two, NoSQL and SQL. Right together, folks. Okay. So I'll just go straight in and just start talking about basically how should I put it? Who can tell me what does relational? One, what is a database? Who can just shout it out? Anyone? A database? Just anyone? Anyone? Jacinta, give it a shot. Kirui, yeah, give it a shot. Nice one. Nice one.
I can say maybe a database is basically a store or where we store data or information.
Nice one. Correct. That's a nice one. Nice. Stefan says it's a store with basically we store data in tables. Nice. So it can either be in tables or not in table form. So today we look at relation. So before, let me just give you a brief story about the two differences. You find when it comes to solutions in the real world, you need to factor in scenarios like one. Are we looking? Is the database that you're going to use, the database type that you're going to use, is it scalable? And how is it scalable? Does the scalability impact the price, which it always does, which it in most cases it does, because you find you can either scale based on the hardware or not the hardware. Are we together, folks? So let me simplify it further. So you find in relational databases, rather SQL databases, when you're scaling it, you scale it vertically, meaning you have to buy more infrastructure for it. But when it comes to a NoSQL kind of structure, database, you tend to scale it horizontally, meaning you don't need to factor in the concept of adding more hardware to it. Are we together, folks? So that's why you find there usually some trade-offs you need to look at. The cost of implementing and how scalable you want it and how reliable it is, things like that. So today's focus is going to be relational databases. So in a nutshell, think of your Excel sheet I think everyone has interacted with Excel sheets before, right? Who hasn't interacted with an Excel sheet? Ah, nice. Almost everyone, which is good, which is good. So when it comes to an Excel sheet, you'll find it has columns. Columns. Each column has particular name, and each row is like a data set, like a data record, a data set put in, rather pushed or added, appended to it. Okay, so that particular structure is almost the same, not directly the same, but it's almost the same as what a relational database has. Basically, it's composed of tables, which are composed of rows and columns. The columns represent the features, or rather the variables to which the variables of that record or that data you're sending to your database. The records, the rows represent something known as records. A record is just like a new data coming, new data coming. Are you together till that, folks? Okay, that's good. That's good. Okay, so now, as you said, in relational databases, you're able to organize our data into tables, which consists of rows and columns. In this case, we've named our rows as records and our columns as features. Let's call them features or variables. Let's call them variables, okay, or attributes of that particular record. Then now, for us to be able to like interact with this relational database, there's a language behind it. There's a language. As you can see, there's some trend here. There's always a language towards interacting and communicating with something. In this case, when talking to relational databases, we use SQL, what is known as structured query language. So it's an interesting language, if I may say. One thing I can alert you in advance is if you're writing pure SQL, kindly use capital letters. It makes it more readable, and you'll be able to know sections that make sense. You can use either capital or lowercase, but it's best practice to use capital letters. That's just in writing. Let's continue. So in this case, we have like it is a scenario where you might have 1,000 records, okay, or even 1,000,000 records, or even more than 1,000,000 records. The question is, how do you distinguish between one record? How do you distinguish between one record and another? And two, let's say within that particular database, you have multiple tables, okay? In these multiple tables, how are you able to link one table with another or relate one table with another? Okay, so to answer those questions, we have two fundamental concepts or two fundamental, let me call them keys. The first one is a primary key. A primary key basically allows you to uniquely identify each and every record. Okay, each and every record in your database. In this scenario, what do I mean? So here we have a particular, I think I can pull up, let me just pull up an Excel sheet, a simple Excel sheet. So just to ask, are you able to see the Excel sheet on the screen right now? Perfect. So I want you to look at this. Forget about all this mad data you see here. I want you to look at this. This column here. Just a second. Okay, this column here represents the particular features of each and every record that is going to come in. Anything after this now, these ones here are known as records. So I'm doing a literal representation, just like trying to explain the key things we've learned. But now the question is here, for as much as we have, for example, this is the column name for this particular column A, right? How do we identify each and every record by itself? We need a unique number. Okay, something unique, something different. So this is where we have something known as a primary key. Are you together, folks? Are you together? Anyone that is lost? if you're lost, please shout. Okay, okay, thanks, thanks. So now we need something known as a primary key. That primary key in outside or rather in applications, there are two common ways of using of creating primary keys. So a primary key can be an integer. Remember, an integer is spans from 0 to infinity, right? You can never deplete it. So like, okay, yeah, you cannot deplete it. It's hard to deplete it towards infinity. So you can either use integers. Integers are just numbers that fall between 0 to infinity and 0 to negative infinity, but seldom a negative number. So you can either use integers or, or you'll find in a scenario where, let's say you're trying to create a solution that is handling user data. But then this user data, let's make it even more simple. You have different institutions, you have like 100 institutions. Out of these 100 institutions, you want to like create unique IDs for each student in all these 100 institutions. If we use integers, yeah, we can use integers. There's no like, rule of thumb that you shouldn't use integers. This is an alternative. So if you look at, let's say, primary school A, primary school B, primary school C, all the way to primary school Z, then you look at if you use integers as your primary keys, you'll find in primary school A, B, C, all the way to Z, you'll have a constant primary key on. So it's kind of, to some extent, it's kind of confusing, or it can be slightly challenging to work around, like to, let's say, map to each and every school. But then if you use something known as a UUID, a unique identifier, it's more easier. It's bigger, but it's easier to now create more unique primary keys. That's just either go to UID or stick to integer, depending on just the use case or just depending on how you think the solution will scale. Are you together till there, folks? Are you together? Ah, okay, so that's okay. That's okay. Now we have a foreign key. Now think about this scenario. So within a database, we can have multiple tables. That's one thing we need to look at. Out of this database itself, we can have, let's say, a student's table. Then the student's table is going to harbor the dormitory table. Then the dormitory table is going to harbor the food table. Let's say not food, but let's say cafeteria table, right? One thing you'll notice here is you can relate a student with a particular let's say meal card or a particular um, cafeteria seat number. Okay. Two, you can relate also this student with a particular dormitory. Okay. So in this case, we are using the student ID, which is unique one. Then we're using it in our table for cafeteria, in our table for what is it table for dormitories. Okay. So in this case, in dormitory and cafeteria tables, the student ID is taken as a foreign key. Are you together, folks? Are you together? Oh, perfect, perfect. Are we getting somewhere, folks? Does it make sense? Does it make sense? Okay, okay, let's continue. Let's continue. Let's continue. Oh, okay. I want to tell you some history, but I can give you an interesting documentary to watch based on this. But it started all the way back in 1970. At times, it's good to understand, or rather just go through, let's say, a documentary or the history about a technology. It kind of just gives you what it actually took to build it, or rather how some things came out of coincidence, some came out of research from, let's say, the army, some came out of just interesting stuff, weird stuff. Even you'd be shocked that you might even get motivation to like build something of your own. Yeah, there's a tool, I guess. How many are familiar with Vue.js? or React? Anyone? Okay, the Vue.js and React, let me stick to Vue.js. They are frameworks for building user interfaces, right? So if you look at the creators of these tools, you're able to understand or rather see the process it took one to take a risk and just go ahead and start building an open source tool, irrespective of not knowing whether it's going to pay you or it's not going to pay you. That's one. Two, it kind of tells you that this was a thought process behind this creator's intention, or rather while building this solution, such scenario. So I'll share one because we'll start Laravel soon. So I'll share one with in today's session by Taylor Otwell. He's a crazy engineer. Yeah. He writes clean code. That's one thing I can say for sure. Yeah. Anyway, moving on. Let's go to. So now we've already understood what SQL is, right? SQL is basically a language that allows you to talk to the database, right? So here we're going to learn about how to orchestrate it, or rather how to write it, right? Okay. So in this case, remember in our when you're dealing with APIs, when we want to talk to the database, there are like four main approaches, like four key. Let's call it a verb. A verb is a doing word, right? Let's call it the four verbs. With the acronym CRUD, create, read, update, delete, right? In our case, with the SQL, we can be able to write syntax or other code that can create a database, create a table, update a table, read a table, delete a table, yeah, and things like that. So we find out of the CRUD, we're able to consolidate it, then have SQL. With SQL now, we're able to now interact with like systems like MySQL, MS Access, Oracle, Sybase, etc. And they basically have an underlying SQL. Some of them tend to tailor theirs towards the ecosystem. Like for instance, MSQL might be using something known as TSQL, Oracle, PL, or SQL, and so forth. Are we together to that? Or have gone too fast? If I've gone too fast, please raise your hand. I can repeat. Joseph, Noreen, Stephen, Hezekiah, and Dorothy. We're together. Okay, awesome. Let's continue. So the question is, why SQL? Why the first default answer is okay. Someone give me a reason, just one reason. Anyone, just shout it out. I'll pick randomly. Lorraine, please shout it out.
Why we need to use SQL?
Yeah. Just one reason.
Okay, just as the initials, SQL is structured query language. That means you can be able to query your database in a way that is structured and has a schema.
Oh, nice. Thank you for that. Nice one. Stephen?
Can you hear me?
Yes, very well.
So it's a common standard that can be used by any individual organization.
Okay, nice one. Nice one. I think I should just clap. Nice one. Nice. So here, as you said, one, it allows users to access data. That is most difficult. You can actually also describe data. We'll see it later on. Then we can use it to find that data in the database, manipulate it. You can embed other languages using SQL. Okay. can create and drop a table right together. So you can have, remember, you can have multiple tables within a database. Are we together? And you can use a foreign key to relate one table to the other, and use a primary key to uniquely identify one record against the other. Are we together till that, folks? Okay, let's continue. So here at the same time, remember, you need to also ask yourself, as much as I'm using this database, I know it's fun to build databases, manipulate them, perform the crude operations, and like store my stuff there and just prepare it for analysis or whatever. But the question is, should everyone access this data? Or rather, should everyone be able to do whatever I can do to this database? The answer is no. So this is where also SQL comes in and allows you like, hey, you can grant permissions to these people, rather particular users. If, for instance, the user is named Kirui, tell him that Kirui can delete, can perform full CRUD, Jacinta full CRUD, Joseph full CRUD, Lynn full CRUD. But then when it comes to I, Joseph, me, I'm only able to read or not do heavy operations, critical operations, such scenarios. Okay. Okay, so when it comes now to like the syntax, we have something known as commands. A command is just a simple please do, okay, please do for me this, or do this for me so that I can achieve this. Remember, the good thing I like about computers is that they are more or less straightforward. Like, give me all that data, that's done. I don't want anything more. So that's the thing I like about computers. And SQL is usually, I'd say it's precise, or rather it's really succinct, the right word. Just check. Exactly. I think it is actually. It's a succinct good one. Like it's very precise. It doesn't have so many stuff to write. But all you need to do is just figure out how you want to achieve what you want to achieve. Yeah. So let's continue this here. So in this case, you can classify commands into groups based on their nature. Okay. A command can be based on just defining the structure. It's based on defining the structure. When it comes to, let's say, manipulation, you can base it on how do I tweak, how do I manipulate this data? Okay. Then the next one is how do you grant access, basically control. So we have data definition language where we define the structures, data manipulation language, or DML, where we enable you to work with your data, insert, include, delete, search. Then we have data control language. Who can access it and how can they access it? Such questions. Are we together? Hello? Awesome. Let's continue. Who has the question? Anyone with a question? Gideon, welcome. You'll be able to interact with the notes, don't worry. Let's continue. So now we'll start off by data definition language, talking about structure. Okay. So in this case, we're looking at, we can create a table, you can modify existing tables, objects, data objects such as a table. We can drop an entire table. So here, I need, like, when it comes to anything related to dropping, I need you to be very diligent. You can drop a table and lose so much data. You can drop a database and lose all your data. So always be diligent. Always be diligent. Yeah. We have manipulation, data manipulation language. Here is where we can look at things like inserting, updating, deleting, selecting. So can we insert data, create new records? Can we update those records? Can we delete records? can we retrieve all records or just one? Good. Then we have control language, either grant privilege to, let's say, Gideon, grant privilege to, let's say, Noreen, Hezekiah, and so forth and so forth. Okay. DML, are you okay with DDL, folks? Big word, but just know we're looking at structures, talking about structures. Are we together there? Okay. When you go to manipulation, DML, are we together? Where we're looking at updating. This, I think this will focus more on insert, create the CRUD, if I'm not wrong. Yeah, the CRUD, create a record, modify a record, delete a record, select a record, or select all records. Are you together? Okay. Now you have the control language. Just give me a second. So here we can have like the DCL, which is data control language. I hope you're together on that point. So let's look at the syntax right now. When it comes to syntax, this is how we tend to look at it. Syntax is more or less like how do you write it? How do you write the grammar? How do you construct your sentence? How do you orchestrate your code? Things like that. When it comes to semantics, now semantics is more or less, does it make sense, whatever you're doing? So now we're looking at syntax. Semantics is something else. Yeah. So let's look at syntax. So here, in SQL syntax, it's followed by any set of rules and guidelines. Those are syntaxes, right? The statements always start with like unique keywords. Those keywords that you just looked in, either based on the DML, DCL, or DLL approach, where you have select, insert, update, delete, alter, drop, create, use. So that's not just examples. There are many more. But it's always preceded with such keywords. But if you're keen, they are all in uppercase. You can also write them in lowercase, but lowercase is not the best practice. Just always remember that. Okay. Folks, are we together? Okay, awesome. Yes, Lulu.
No, I don't have a
okay.
question.
Okay. So now the thing is, when you write your SQL statement, you've already preceded it with a particular statement and a particular operation you want to achieve. So one thing you need to know is this particular semicolon will punish you. It will punish you properly. Because if you don't put it, it's telling the computer that hey, this fellow over here is running an SQL command, right? But then I can't see where it's stopping. So should I look for more? And when I look for more, there's nothing beyond it. So it tells the machine that hey, this fellow's SQL command or query starts here, ends at the semicolon. All right, together. So as we discussed earlier, SQL is case sensitive. There's a difference between capitalized, let's say, home database. If you write, what can we write here? Let's say, let me put it on chat. Let's say database is called my student, something fancy. Student is so common. My food database. That is scenario one. But then you come and try and access it using my wood database. Those are two different databases. As much as they, according to us, semantically, it's the same thing, right? Like it's just the only thing that makes it different is one is capitalized and the other one is not. But according to the machine, it's going to match it and say, okay, you have the my food database, right? But it doesn't match this other my food database. Are we conflicting somewhere? Things like that. Are we together, folks? Okay. Okay, let's continue. Let's continue. So we're going to look at basic syntax. So today I just want to explain visually, like this is like what we want to do. So I'm going to just tell you like this is the syntax. Then when you go to the assignment now, you're going to now do it practically. There'll be like 3 assignments this week. 1 for writing, of course. 2 will be more or less like going through a 1 hour to 2 hour course. 2 hour, no, 1 hour, it's actually 48 minutes. 48 minutes like deep dive into SQL. Then the third one will be based on you creating a solution. Yeah. So here we're looking at the syntax for creating a database, right? In this case, we have, remember, starts off with the keywords here, the keywords here, create database, then the database name. So I want you to look at a scenario where all these are in lowercase. That would be hard to read, right? Or rather hard to manipulate, right? So in this scenario, like, it wouldn't be as readable or as visually distinct because they'll be on the same cases. So that's why you tend to use create database to explicitly say that these ones here are SQL statements, then this one here is now what I'm trying to build or create. In this case, the database. So create database, that's SQL based. Database name is the name of the database, then semicolon is the delimiter or where you're telling the code to stop doing its stop. Yeah. The next one is when you want to like see all the databases present there. So in your system, you can have multiple databases. Okay. Now it will reach a point, let's say you want to see, okay, in my server, my server space is reducing. What is going on? Okay, let me check which databases are here. Okay, then let me check whether there are some that are active or not active. So you can use this maybe in an instance of doing, let's call it, it's like more or less like an audit of sort. Until there we together, folks. I don't want to leave anyone behind. Okay, does it make sense? Does it really make sense? Okay. Let's continue. If it stops, just shout out. Say, read, things are gone south. Okay, let's continue. So now let's look at a scenario where we want to delete or drop a database, right? So remember our approach. One, the SQL statements are capitalized, they're in capital, right? Here we have drop database, right? Then we have the database name. So here, you have to be really diligent. I'm telling you, I've been in a scenario where luckily it was just test data, where we were recording, we were pushing location data for a particular device we were monitoring. So the device would send data to the cloud, send us the latitude and longitudes, then it would send it all the way to our database, which was SQL based. Then afterwards, we would plot like a graph, we'd plot the trail on a map. And now that it reached a point where we were trying to achieve the same. We were trying to manipulate something. So we said, let me drop this database. Then I see what I can build on top, or rather build another database. So I ended up dropping the original database. We lost a lot of records in terms of distance, the latitude and longitudes, and even the payloads, basically the payloads. So be very diligent when you're doing this. In fact, you can even base it on like only give the admin the privilege to drop the database. It's very, very important, very important. And it can cost a lot. Okay, a scenario that can make it vivid is imagine you're recording pulse data of a patient. This patient is supposed to be, whose vitals are supposed to be seen before, let's say, Saturday or rather Friday, where on Friday is going to go for a review. Then you drop the table. You drop that particular database. You have finished that person. Finish that person. Let us continue. So in this scenario here, as much as we've already looked at creating a database, right? We've looked at, let's call it like this caliber of creating and deleting. Okay, this caliber comes in and says, okay, I'll create this table. Second one says delete this table. But then now, after doing all that, you've created a database. You can now select a database. Tell the system that, hey, I know there are many databases here, but I only want to use this particular one. Have it together. For instance, the students database, the school database, you can have a database, let's say for the billings database, things like that. So in this scenario here, let me just take you straight to the syntax here. We've already discussed this. Here we have the keyword use and the name database. So remember keyword or SQL statement, then you have the name of database and the semicolon. That's the limiter. So here I'm telling the application, please use this database. Here we're telling it, please drop this database. Here we're telling it, please create this database. After creating it, show me all the databases that are in my server. Try it together. Try it together, folks. Okay. This is good. This is good. So let's now proceed. So when it comes to now creating a database, you've reached a point where you've created a database. This database is going to harbor your tables, right? The tables are usually like distinct bodies or objects that contain data for a particular, let's say, case. For instance, let me put it this way. Now, be in an institution, right? The database can be, let's say, StratFordDB, right? StratFordDB will tell you that, hey, StratFordDB has multiple tables. The tables can be one, tables for cafeteria, tables for billing, tables for, let's see, this is students themselves. Yeah, student. No, let's not put students. Let's say the buildings functional, buildings, yeah, buildings, something like that. But then you see within this particular tables, remember I spoke about records and columns. So when you're writing about the columns and when you're writing about the columns at hand, you find each column has a particular type. So by type I mean, is this particular type integer? Is this particular type let's say a string? Is this particular type float? Is it Boolean? What is it? So I have a question, a quick question. Is everyone familiar with data types? Or should I explain? If I should explain, please raise up your hand. Maybe Dorothy, Joseph, Hezekiah. Okay, so nice. Okay, then that's okay. That's okay. No need of me explaining. That's okay. Thanks for that. So now you find with each particular column can harbor a data type of a particular sort. And the data types here, they are identified in this way. These are just a few, but there are more. Okay. So look at let's start with the varchar. The varchar, it's like a variable character where it holds a variable of length string that contains up to 55 characters or special characters, right? Then you have tiny text with a maximum length of 55 characters. So in this case, remember, the size of your text also determines how SQL optimizes and saves it in the databases. Okay, so in this scenario, you find these are just some of them. So let's say in a scenario where you want to use, let's say, you want to create a mini blog, right? So this is how I do it. On the blog, you'll have a title, you'll have a subtitle, and you'll have a, let's assume you just need to put everything on one text, everything on, let's call it on one text, the content, the body, marks and the introduction in one whole text file. Then you do the processing. You let the front-end developer do the processing by himself or the structuring by himself. So in that scenario, the title can be a varchar or a tiny text. Then the title, the author, the pages can be an integer because you can't have like a page above, I think, a million. It will be an integer basically. Then you can have the author is a string, which is just going to take varchar. And here, one thing I needed to know is, you see this varchar, you see it has like parentheses in the size. You can explicitly say that I want this varchar to only hold 5 characters. Okay, so a string is composed of an array of characters. A, B. Let's say you're talking about let's say school. School is a string, but it has SCHOOL characters. Those are all characters. Are you together, folks? Together. Awesome, awesome. Let's continue. So now we can have blobs. We can have doubles and large numbers. You can have a date. Then for let's say like text that is very long, you can use long text, something known as long text. So you can just check up. I think I can pull up a link for data types. There are many. So the question is, you just have to ask yourself, what am I trying to achieve, and how will the database store this? Are you together, folks? Okay, let's proceed. Let's proceed. Let's proceed. So as you can see here, we're noticing that the data type is usually dictated by the nature of data and the intent and by the intended use. So how does this data look like? And what is the use of it? How do I want to use it? Do I want to use it as a number? Do I want to use it as a long text? How do I want to use it? So you should be keen about it. Because in traditional scenario where you want to, let's say, query your data and perform, let's say, manipulate it. In that scenario, you'll find, can you really order text data? Things like that. Can I really order my records based on time or my date? Are we together, folks? Scenarios like that. Scenarios like that. Okay, so we're going to go straight now. So we've looked at some basic syntax to create DB, drop, select, and then some data types here. So let's proceed. So here you're going to create a table. Okay, remember a table is composed of multiple rows and columns, and out of these multiple rows and columns, they have their different in the columns, we have different types that are stored within those columns. And for this table, you have rows. Rows are taken as a records themselves. So in this scenario here, what you are doing is you are creating a table. Okay, this table one has the name and the type. Are we together, folks? Name, type, name, type, name, type, name, type, name, type. Are we together? Okay, nice. I like that. So now here you see, you notice something. The first two entity elements here, create table, is now the statements of SQL, right? The persons represent the name of the table. We together, name of the table. Then we open a parenthesis and close a parenthesis. Within this parenthesis, we define our particular variables or columns. Are we together? So the variables or columns are have a name and the type. Name type. What you see a personal ID type is it. Last name varchar. Then this is the varchar variable character. So here this tells you the maximum number of the number of characters. Basically, you can even reduce it to 20. Then same to this, same to this, same to this. Are we together till then? Perfect, perfect. So then now you to the point where you want to like you're interacting in the database that you don't know the structure of. Well, let's say you've just been given a whole server and you were told, hey, please go into that server, check whatever databases are there, then check for me what type of tables are there and what data they hold. So in this case, you've already gone through the process of going to a database, check using a database. So in this case, you've created a table, but then now in a scenario where we know the table exists, but we don't know its elements. This is now where you can check, you can use the desk keyword persons, for instance. Person is for the name of the table itself. Desk is just a keyword for SQL that tells you like, hey, one, it's going to check, does this table exist? Two, can I get details of this table? As simple as that. Proceed. So just to clarify, I hope you're moving together. I hope you're moving together. Yeah, I hope you're moving together. Awesome, awesome, awesome. So in this scenario, yes, it's Lorraine, you have a question? Am I okay? Okay, that's okay. Now let's go further. Let's go further. Now we want to look at a scenario where we want to insert data into our database. Okay, basically adding more records. In this case, you're going to have interesting keywords. You're going to have insert into, then values, right together. Here, however, you have insert into is a statement that tells SQL that you're intending to insert a new record or create a new record. In this case, it's going to say insert into, then this here gives you the name of the table itself. For instance, persons. But then here, you explicitly say, okay, in this particular table, I want you to only target this particular column names. So here you can have age, what did you have this as it? Last name, first name, address, city. Personal ID, last name, first name, address, city. So you place them here. Are you together, folks? Okay. Then now, once you've placed them there, you now come and say, hey, so I am intending to write this to add a new record to my database, right? So now the question is, which values am I adding to that database? Rather, what am I adding to that database? In this scenario, it is we have values value 1, 2, 3, and 4. So this will be the values that will be added to this particular columns, and now we get what is known as a record. Remember, don't forget your semicolon. Let's proceed. So now we go to select. So in a scenario where we want to know, let's say we want to read, or we want to like target a particular column or target a particular, basically column, usually target columns. So in this scenario here, what you're doing is we're going to use a select statement to fetch the data from the database. You can fetch one record or you can fetch all records, okay? Or you can run a complex query. We'll run the complex queries later on. I'll show you the complex queries later on. But for now, think of it like you can run queries that allow you to select all from the table or select particular items from the table. Okay. In this scenario, the last one here where we have an asterisk, the asterisk means select everything from that table and give it to me. So we have the statement select with a space asterisk, then from the table. From tells us which table name, then a semicolon. Are you together? Folks, are you together? Awesome, 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 awesome. So continue. So it is to the point where you want to now add like conditional statements, telling like, I want you to select this particular record from here, where, for example, the color is blue or the index is 10 or something like that. And so in this scenario, what where does is it allows you to make tell SQL I need you to make a decision based on my particular condition and give me something out of it. Let's go deeper. So here, it's a lot of words here, but just know where what it does is it's going to first of all have the select keyword, Then you can have your target columns if you want, ID, name, salary. Then then this is the table name here. So in this case, remember table name is case sensitive. So if you created a table in capital, you should write it in caps. Otherwise, write it in small. Then you see where salary is greater than 2,000. This here represents the condition. This here, and this here, actually they're in the same row, same column. Select from and where are the statements. ID, name, salary, and the columns customer is the table. Then salary is the column. But within the salary, you're trying to target those ones that are above 2,000 shillings. Okay, then you select column. Right together till that. If I may ask, just to ask based on feedback, does it make sense? Like, are you understanding? Does it make sense? Or would you like me to repeat something? Okay, let's continue. Let's continue. Feel free to talk. Feel free to feel free. Let's continue first. So we've looked at basic syntax. We've gone from the creation. We've gone to the deletion of a data, creating a database, deleting a database, then proceeding further to now selecting entities, elements from the database. Then again, we've looked at inserting records to a database. Okay, so we can also update a database. So in this case, the same create reader, create the CRUD process. When it comes to reading, updating from a database, you can either this is update or delete. This is delete. Yeah, I mixed the two. So I'll replace that. Let me just do it now. Sorry for this. Just a second. And you think faster than right? I think it's okay now. So here, let's go to update, then delete. So updating basically says that, hey, this record exists, right? But then I want to update the values of this record. So look at a scenario where you've created a beautiful shopping application or an e-commerce application. With this e-commerce application, you have a list of items, or rather a list of items you're selling. Out of this list of items you're selling, you find that one of the items, let's say you're selling bottles of water. The bottles of water have a brand, they have a supplier, and they have the quantity. Anytime you change the number of quantity after a sale from either 100 to 50, that's an update. Anytime you change a supplier, you're going to also change it in your system. Let's say from the supplying from Waniki's customs, and now you're taking it to Jonah's customs. You see, those are updates you're making. So one, the first rule of thumb is the data already exists. Two, you're trying to update particular columns or particular features. Okay, here's the syntax. So here we have update as a keyword. Remember, we have the statement, we have either the table name, then we have what you're going to set or you're going to change. Are we together? So here, I want you to look at this. We have the update customers. This is the table name. Set is a keyword that tells you set change address to Pune where the ID is 6. Okay. In this scenario, I'm assuming ID has been used as a primary key. Are you together, folks? Let me repeat. Here we have this whole syntax here. We have the keywords update and set, right? Update, set, and where. Update is going to tell us what do you want to update. I want to update this table named customers. In that table named customers, what do you want to change? You want to set the address to Pune. Are we together? So here we're changing the address from whatever it initially was to this new one. Then we're going to say where ID is equals to 6. So whenever the ID is 6, change the address to Pune. So that's one way you can, that's one advantage of using primary keys. Otherwise, you'd have been going through the whole data, you search, you say, okay, let me go to the name and check whether this name is equivalent to this individual's ID. But then you find this individual's ID name, the guy has two names that are the same as another fellow who has two similar names. What makes them different? Okay. Let's call it a third name, things like that. But the ID gives it more unique value, things like that. Right together, folks? Okay, let's continue. We go to delete. So in this case, this is a point where you want to remove data from your database. So in this case, we use the keyword delete. What delete does is it's going to have three keywords here. You can either delete from customers where ID is equals to 6, where you have delete from are the keywords, the statements, even why is a statement. Customers is our table name. ID is equals to 6. We are matching where the column ID is equivalent to 6. We're using the primary key basically. That's the scenario at hand. Let's continue. So then it comes to and or statements. I remember I asked you to look into Boolean statements, right? Boolean, the truth table. How many people looked at it? Boolean table, where true, false, such true and false. How many looked at the truth table? Okay, then I'll urge you to look at it again, and I'll draw a structure and just send it to you on WhatsApp. Okay, let's continue. So the AND operators are usually mostly used to increase complexity of your condition, because at times you find you want only to filter out, or let's say delete or manipulate the data that is there based on, let's say, if the salary is greater than 2,000, and let's say the location is in Nairobi. You see, on a scenario where the salary is greater than 2,000, or the location is in Nairobi. So in an AND scenario, both conditions must be true, otherwise false. In an OR scenario, either of the conditions must be true for it to be true, otherwise it will be false. Are you together, folks? Okay, nice one. Thanks for that. So in this case, let's go to our syntax to see here. So remember, we have our particular keywords. Our syntax is select from where, and those are like the SQL. Let's call them the SQL syntax. So we select these target columns from this particular table, where the condition is this are met, or you can have this or this are met, depending on what you want to achieve. So what can help you do this is, in a scenario for, let's say, an e-commerce application, you can look at a scenario where the user, if the user is in Kenya, and the current scenario in Kenya, let's say, is electronics are booming. People are buying so many electronics. In particular, let's say people are buying walkie-talkies. So you find if this person is in Kenya and wants to buy something, is intending to buy something, show them all the walkie-talkies at first before you give them something else. That's another scenario. Feed them first with what they frequently say. Let's continue. So the like clause is just more or less taking, like, is it equivalent to them? And together, like, are these two elements equal, such as so you're able to compare two values to check whether they're similar. but you can also use wildcards, a wildcard. So a wildcard can be used like together with the like operator. You have a percentage sign and an underscore. Let me see if I put an example here. Ah, yes, I have an example here. So here, let's make it more vivid. So assuming you've already written the first manipulation, either the DML or the DML. Let's call it yes, it's the DML approach where you're trying to manipulate the database. So once you've written precedently to that, you now come to the condition where you have like where customer name like A was it. So it will look for anything that starts with A. If you interchange, it's going to look at anything that ends with A or have or main position. So this one, it's more or less like I take it like a regex, a regular expression of sort. Are you guys familiar with regular expressions? Who's not familiar with regular expressions? Okay, let me explain it. How many have interacted with login platforms where they are being told that one, your password is missing a unique special character. Your password is missing a capital letter. Your password is missing lowercase letters. How many have interacted with such functions? Ah, perfect. So to achieve such, you can use something known as a regular expression. It kind of allows you to enforce a structure in a way. So in this case, for the like clause here, what it's just trying to do is like it's going to match, but then your matching can either follow either after or before such a scenario. So it's somewhat close to rejects, but not rejects. Yeah. So it's like it's telling you like I am looking for all entities that start with letter A, or all entities that start with A and end with O. Right together, something like that. So let's go to order by. So when it comes to order by, it reaches a point where you want to understand or order your data, basically in ascending or descending order. There are just two ways. So in this case, yeah, you can choose maybe order by the name of the customer and the salary. Right together. So we have a keyword here. Order by also is a keyword, then asterisk, and also from. So select all from the customers table, then order by name and salary. Are you together, folks? Then use my column. Who is lost? Who is lost? Do I have video? I repeat, yeah? Okay, just enter, yeah. Ask away.
Yeah, I want to know when you order by name and salary, how is it? How does it appear? Like,
How is it going to structure?
Exactly.
This is a good question. If we order by name, we can now let's say if we order by name, it's going to take a default of ascending order, right? But then when it comes to now salary, it's going to check the highest salary in ascending order. Let's say in the group of A's, highest salary in the group of B's and C's, then orders it. We can try it out practically. Yeah, we can try it out practically, but that is my assumption. Yeah. The second bit. Oh, more questions. More questions. Heroine, Dorothy, Hezekiah, Gideon, Stephen, and Lauren. Questions? Okay. Yeah. Oh, let's continue. So in this scenario here, we have where we select all records from the customers, then order by the name. Desk is more or less like in descending order from Z. If it starts on, it starts with Z. Is there any, how many names are there that start with Z? Zachary, Zephaniah. It's interesting. Okay, questions, folks, question. Okay, let's proceed. Now, this is a good example. Well, let's say we want to, the example is known as select all from customers and sort the results in ascending order by age. So here, what you're going to do is, who can write the statement on chart? Anyone, write the statement on chat, then you confirm whether you're right or wrong. Jacinta, it. Oh, try, anyone to try. Okay. So basically, here the objective is we're going to select all. So we'll have a simple select asterisk from customers. So we just follow this. So we okay. Nice. Lina's wrote it. Nice, perfect. There it is. Nice one. Nice one. Nice one. Nice one. Nice one. Nice. Nice one. Nice one, Lynn. Nice one. Nice one. Select all from customers by let me just select all from customers in order by age. This is perfect. Same to Janice. Perfect. Remember to put a space after select, but perfect, perfect. So remember by default, the order by takes in ascending order. Then now we sort the result in a descending order. So we can sort again by in descending order by using the DES keyword, which is same approach, we're just adding this at the end of your statement. Oh, Lynn would have got it wrong because of the semicolon, but you're right. Nice one, Jacinta. So another one would be now group by. In a scenario where we want to, nice one, Kiri, nice one, Kiri. Nice. From customers order by age. No, it's order by salary, not age. Yeah. But also nice try, nice one. So let ID name, age, address. This is interesting. At least okay. For the descending, we're supposed to order by the salary. Yeah, but nice one. At least we can see you're getting some selects and asterisks here. Yeah, let's proceed. So the group by, what it does is it just basically groups it based on similarity. So you can combine it with the select. Say, this is select column 1, column 2 from the table, where this particular condition is there. Then you group it by column 1 and something like that. Basically allows you to group particular related, or let's call it related entities or related columns, basically. Yeah. So the syntax is basically this. You can select all, or you can select the target columns from the table name, the table itself, where the condition is this. This particular condition is met. Now you group by, then you order by. Okay. It is 15. So here's an example you can use. Yeah, if you want to know the total amount of salary of each customer, then group by query would be as follows. So here we select name, sum of salaries from customers, so then we group by name. So basically, if Ramesh was being repeated, it would look for another Ramesh, then append it or add it. So in this scenario, it hasn't added it. It has only taken Ramesh 2000, Kilan 1500, Koshik 2000, so forth and so on. Are you together, folks? together. Okay. Distinct allows us to now check, remove the element of repeated items. So in this case, distinct is just as it is. Pick those unique elements, entities in those particular columns. Okay. So it can be used to eliminate the duplicate records and fetch only the unique ones. So here's a scenario at hand. Here's the syntax. You select distinct salary, which is the column name from the table customers. Then you order by salary in a single column. So select the unique salaries from the customers table. Then you order by the salary, which is from the highest to the lowest. Are you together till that? Are you together, folks? Does it make sense? Okay, okay. Views I'll give you as it will be part of the assignment. But it's just basically an SQL statement stored in the database with an associated name. So I think this one is best if you do it as an assignment on a practical. So this one I'm going to skip it for now. This I will skip it, but we'll have it in our assignment. So for views, I want to create that view and go straight to exercise. Yeah, let's go to the null values. Null values. So it will reach a point where you want your payloads to be able to accommodate null entities or non-null entities. A null entity means that it's empty. But if you want to enforce that it must have a value towards it, we invoke that is not null. Is not null allows you to tell me that this shouldn't be empty, something like that. So there are ways there are two ways you can do it. One, you can explicitly say it within your database as you're creating a table and state that here in this particular table column, it should not be empty or it should not be nullable. We'll see this later on. But in a scenario where you want it nullable, you express it as null. So here now we're looking at a scenario where as you're querying from the database using SQL, right? From this SQL, we're trying to check whether it is empty or not empty, basically. So that's why I have like select column names, let's say this particular column names from the particular table where the column name is null. So give me everything that is null. Wait. Then here, we're going to talk about the ones that are not null. Are you together, folks? Are we together? Okay, that's fine. That's fine. Let's proceed. So in this case, address in row 2 and row 3 are null. But then the other ones, last name, first name, and city are non-null. Okay. So I think this can be, I think you can try and write it. You can try and write all this. Write it on chat anyway. Just write it on chat. Like 2 minutes, 2 minutes, or 3 minutes, write it on chat. It's done. It's done. Anyone? Dorothy, Kirai, Jacinta, Lynn, Lynn, Stefan, Gideon, Hezekiah. Anyone? part of the assignment. Oh, Lynn is typing. Ah, nice. Let's see. Nice. This is good. Let's see. Oh, here's a hint. Oh, here's a hint. You can. Here's a hint. Here's a hint. I'll give you like 2 minutes. 2 more minutes. Select all from table where address is null. Select all from persons where address is null. So let's look at it. One, we have suppose that the address the address column in the persons table. So address is supposed to be, write it as it is, capital A, address in the column of persons. In the persons table is optional. If a record is inserted in no values for address, the address column will be saved as with a null value. So write an SQL statement that uses the is null operator to list all persons that have no address. So in this case, we are going to check whether it is null, right? So we'll have select all from persons where address is null. Perfect. That's a perfect one. You've pasted it from ChatGPT. Lorraine, you've pasted it from ChatGPT.
No, I didn't just ChatGPT.
Okay, it's highlighted. Okay, it's fine. It's fine. But it's correct. It's correct. It's correct. So the other one is SQL. The other one is write an SQL statement that uses is not null operator to list all persons that have an address. So here we're going to use, they just change it from is to is not null, basically. Yeah, so Kirui, you're right. Lorraine, you're right. Lynn, you're right. Yeah. Oh, this just one thing. This one thing you need to be keen. Actually, Lorraine, there's something you missed here. You've selected all from persons from address where address is null. So that one maybe you can look into. It's not you're close to yeah. Yes. Thanks. Okay, at least I can see some progress. I can see some progress. Mark. Let's continue. So we are also able to check this basing it on numerical values. We're also able to check the minimum, the lowest value and highest value in a particular column. So in this case, we have, let's say, we have the functions min and max. So we can have select the minimum value in this particular column from this table where this condition is met. Okay, right to that. And same to the maximum. So it basically allows us to check what is the highest value here and what is the lowest value in this particular column. Okay, that one is very simple. So another function is the count function. Count function basically tells us like, okay, which particular columns match this particular criterion of condition, right together. So it basically returns the number of rows that matches a specified criterion. Let's look at it. So we have, here's the syntax. It's not a syntax at first. We have select count, then you have the column name, then you have from the table where the condition, this particular condition is met. So we can check how many items within this particular supermarket, in these are cases of supermarket, have prices less than 20 shillings, less than 20. So here we are targeting the price column from this shopping table, yeah, where price is less than 20. Are we together, folks? Are we together? Should I repeat? Should I repeat, folks? Should I repeat? Okay, let's continue. Kirui, Jacinta, Dorothy, Doreen, Gideon, Joseph, Ezekiel, you guys okay? Please, if you're not, please just shout out and explain. Okay, okay, let's proceed. So another one is an interesting condition where you want to check whether it can fall. Let's say a particular condition, let's say price can fall between 10 and 20. So here in this scenario, we have select all from products where price is between 10 and 20. So for instance, it's less than 20 and also greater than 10. 20. Okay, so there's a range that has been given. So you can look at it, from a perspective of a shopping application, or let's say, think of your house, the things used in your home. Let's say toiletry, let's say foodstuffs. When the moment the quantities are within this range, you need to start planning to purchase more. That's how like you think about it, and that's what like you do on your database. So select all from this particular product where the price is between 10 and 20. So the quantity is between this and this. Just a minute. Hello, sorry about that. Yeah. Okay. Does it make sense till that point, folks? Okay, okay. Yeah, in some this is good. Good. Okay. Let's continue. So now, let's look at combining. This is the scenario where we are combining whatever we've learned from uh, so far to a single operation, where we have a scenario where we are populating one table using another table. So in this case, we are inserting into the first table this particular columns, array of columns, column 1, 2, all that column n. Then we select column 1, 2, all that column 9 from second table where this particular condition has been met. So the best way to see this is through a practical. So part of the assignment, you find challenges like this to which you can build upon. You can push it. You can push the solution either through a mini documentation, or let's say GitHub version control it. Let's talk about the story of SQL. Yeah. So it reaches a point also we need to like it's an instance you've seen earlier where we want to join multiple tables. So the challenge when it comes to joining multiple tables, this is where you need to be very keen, very keen, because you can do a particular join of a table and you lose out on particular entities of your data. So you can end up losing your data or gaining from your data. Or if one table has multiple null values or less null value, this is something you'll have to compromise. So when it comes to joins, it's called a join, basically combining tables, data from multiple tables. When it comes to that, there are particular types of joins you can conduct. You can have an inner join, a left join, right join, and a whole join. And let's start with an inner join. The inner join returns a row when returns a row when there's at least one match on both tables. So meaning if it matches on table 1 and table 2, give us something. There's a match, right? On the left join, it matches rows from the right table. Right together. If it's located here on the right table, bring it right together. The right join now returns all rows from the right table and matched rows from the left table. Okay. So it's basically where am I joining from? Not just then a full join as well. That is a matching one of the tables in our propensity. So well, choosing which join to use is dependent on one, how you want to how consistent you want your data to be. Do you want it to be consistent based on the first table or the second table, or do you want to be consistent based on the other way around, or do you want it to be consistent, or don't you want it to be consistent? You want anything to match it. Such questions, okay. But how you merge it is very important. Very important. So I'll give you a scenario that can cost a lot. If you're merging data, let's say financial data from, let's say, two different locations, let's say actually two different types. Data one is having information from, let's say, 1955 to 2100. Data two is having information from 1955 to 2100. You know, the thing is, it's been grouped, let's say 1955 to 1960, 1960 to 1965, and so forth and so on. So you find in a scenario where you're trying to merge the two, it might conflict because you might lose one match. Okay, so if you end up losing, let's say data from the primary one, about the left one or the right one, you might have to look at what am I sacrificing out of this? Let's just be a great time. Are you together, folks? Who's lost? Okay. So the joins, the combining tables also provide more resources on it. We're done. So here are three things. W3 schools, it's going to give you a whole like structure, like the whole SQL story, right? For the academy, it give you like a short mini course of SQL, very important. I found this book quite interesting. It's a short book, like 200 and something pages. I hope you got access to the other books, right? I shared 2 books. Did you guys get access to it? Okay. If you started reading it, I think you're enjoying it really good by now. Yeah, if you started reading it. Anyway, that's the end of today's session, folks. And I just wanted to ask if you have any question, if you have any concern, or if you are for a parting shot for today's session, please reach out or just feel free. The floor is open. Even a reflection might say, cool. A lamp that is clear databases are relational in nature, or they are based on tables, or there's a table, this particular table has columns, the columns have, and they also have rows, the rows are records, something like that. So any reflection, any comment? Yeah. This is our third session so far. How are you faring on? How are you faring on? Are you surviving? Are you understanding? Are you drowning? How are you faring on, folks? Zuri, Jacinta, Lynn, Dorothy, Stephen, Joseph, Zakaria, Andrew. Okay? Are you sure it is okay? Okay. If there are any challenges, please reach out. You can share your articles on the WhatsApp group. I'll start reading them now. I think I should only take at least 30 minutes. And I'll comment also. Yeah, you will get a new follower today. Yeah, for the codes, you can share them as well. I'll review them, run them, then get back to you. Tomorrow's session, we are handling. Oh, Kiru, you're not in the WhatsApp group. Sessions are good and simple style. Let me just inform. Let me inform Phyllis of it. Let me ask her to add you to the WhatsApp group. Just a second. Okay, she's going to sort it out. Okay, so the wording I've already sorted. Okay. I hope the sessions make sense. And okay, simple to understand. Nice. So tomorrow you're going to handle NoSQL. NoSQL is kind of interesting. Doesn't have a lot of things or interesting stuff, but it is interesting. It is interesting. Yeah. So I will see you tomorrow virtually. Please see you tomorrow. Yes, Jacinta.
I have a question. When you're using SQL, the
Yeah.
approach I've come through is where you use a Jupyter notebook, you create a SQL environment. So I wanted to know, is there an alternative, or can SQL stand by its own? Like you just work with SQL by its own?
You can work with SQL by its own, but then remember, to think of a scenario, SQL just comes in for you to talk to the database. So you need like a form of medium or interface, right? So in this case, if let's say we're interacting directly with the database, here we're looking at what do you call it? What do we call it? It's called the terminal. You're familiar with the terminal? Oh, yeah, a terminal.
Yes, I am.
Oh yes. So now you can be in a scenario where you don't have any other tools. So you go to the terminal, SSH to the server. Then now you start talking. You initialize a SQL instance. Then now start talking to the database itself. So such a scenarios is where you can just use purely SQL commands. Another scenario is when, let's say, you can use other languages to embed SQL to your code. And one thing we learn is that people who have seen that the SQL syntax is kind of a lot. It's a lot. So now what they've done is they've created an abstraction towards interacting with it. So something we will interact with in Laravel called elephant. I find really interesting. I don't know if I've answered the question.
Yes, you have. Thank you.
Okay. Lynn, talk. No, Lynn, can you share? No. Oops. What we do? For code to be shared, connect it. Yes, Dorothy. Yes, just have more greens. Remember, add more greens to your GitHub. You kind of have an impact. Add more greens. I'm also much in the WhatsApp group. Let me also let me inform Phyllis. So and also in so okay, that's the end of today's session. I really appreciate you taking the time to come this afternoon to have this session with me. I've learned a lot from you, and also thank you for being really fun to teach. Okay, have a blessed evening, and I'll see you tomorrow, folks. Okay, that's the end of today's session.